Quiz Prep, Chapter 7.2 and 7.3. Hello everybody, welcome back to Quiz Prep, only this time it's the sequel to Quiz Prep 7.1. It's Chapter 7.2 through 7.3. So in this episode, we revisit Gitlin and colleagues and their study of chronic dialysis patients and their Charlson comorbidity indices. That's the plural of index. I feel smart now. Okay, if you remember in 7.1, unfortunately this group is kind of sick. They had a Charlson comorbidity index. The mu of that population is 4.3. The population standard deviation is 2.5. And what this quiz prep is really about is calculating z-scores. So let's get started. Hi there. Okay, so this is question 1, and we're going to get into calculating z-scores, but I just want to tell you I cannot explain in quiz prep what a z-score is. You're just going to have to learn from the rest of the class, the rest of the course, the information I'm delivering, and the textbook, what a z-score is. What this part is about is how to calculate one. So I put, therefore, up here in the upper left there, that z-score formula, right? So that's how you get z. And then you'll notice in the formula there's an x, there's a mu, here's the x, here's the mu, and here's the population standard deviation, right? So we have to fill in the mu and the population standard deviation. This is Gitlin's patients, chronic dialysis patients. So where's the x? Now everybody always asks me that, and I always say the x is in the question. So what's the question? What is the z-score corresponding to a Charlson score of 5? Well, 5 is the x, so x equals 5. So let's calculate z-score. So how do we do that, right? Like we're going to use that formula. So x minus mu over population standard deviation is the same as, let me change color here. So our x is 5, right? It's in the question, minus 4.3, 4.3. And then you divide that by 2.5. And if you get that far, you're going to get 0.28. Right? So that's the z-score. Not very hard, is it? Okay, and here we are with question 2. We're kind of going to do it again. But I just wanted to point out, in question 1 before, so question 1, the x equaled 5, right? And the answer we got for z was positive 0.28. And the reason is because 5 is actually bigger than the mu. Okay, so we're going to have a different story this time, because our question 2 is, what is the z-score corresponding to a Charlson of 2? So you feel like a pro now, you know how to do this x minus mu over population standard deviation, which we're going to plug our data into. So where's x? X is in the question. So we're going to know 2 minus, then up here 4.3 divided by our old friend 2.5 equals, now already you can see what's going on here. 2 is less than 4.3. So the top of the equation is going to be negative, and that's not helped by the bottom of the equation. So this is going to be negative. And so sure enough, it is negative. It's 0.92. The reason I make a big deal about this is you should be able to check your work on this. If the x is less than the mu, you should get a negative z. And if the x is greater than the mu, you should get a positive z. All right? Moving on to question 3, which is similar to 1 and 2, but it's a little different, okay? This one asks, what are the z-scores corresponding to a range of Charlson score here? A range from 1.5, which isn't so bad, to 4.5, which is a little bit bigger than the mean. So what would you do with that? Well, basically, what you do is, this is an x, and this is an x, and how you tell them apart is you label one x1 and x2. You put this down. Not like x to the second. You know how that's up here? No, it's not like that. It's x2. This is like its name. Um, all right. So what this means is you get double points for this question on the quiz because you have to do two things. So let's start with x1. All right. Oh, let's choose a different color. I'm so sick of red. It's so alarming, you know. Okay, so uh, I don't know why I just love to rewrite the equation. It just gets me in the mood. All right, so that's the equation. So how do we fill it in for x1? So we'll see z. So I'm going to say put a little 1 in there. Okay, z equals, well, what was x1 is 1.5, right? 1.5 minus 4.3. You're going to memorize these mu and standard deviation by the end of this. Divided by 2.5 equals, and so is this going to be negative or positive? Well, look at this. It's smaller than 4.3, so it's going to be negative. And what is it going to be? It's going to be negative 1.12. How about that? Okay, so that's x1, right? x1 is x1 equals. All right, now you got that? Let's just erase all this messy, messy, messy. And we're going to do x2. Let's see here. I'll put this back, but I'm going to choose a different color. Maybe we haven't done orange yet. So we're going to do x2 here. So let's do x2. So what was x2? 4.5. So we're going to do z equals 4.5 minus 4.3, and again you'll notice 4.5 is bigger than 4.3, so this is going to be positive. Divided by 2.5, you're used to that. And now we're going to get 0.08. So technically then the answer is change colors. For this range, the range of z-scores is going to be negative 1.12 all the way up to, this should be like 0.08. Okay, just a quick check-in with you. Back to quiz prep. We just filled in question 1, question 2, and question 3. Now we're moving on to question 4. All right, now we're moving on to questions 4 and 5. And you'll notice here I'm getting ready to do those, but you'll notice something special on the slide. You'll notice that there's this new equation, a brand new equation. Well, it's actually not a new equation. It's not that new, because you'll notice the ingredients in this equation are the same ingredients in this equation. So what did I do? Sneaky little algebra. What I did, well, I didn't really do it. Brazy and Brazy did it, but I got this x to be isolated over here alone on the other side of the equation. Well, why would you want to do that? Well, that's what you'll notice about the first questions that were asked, 1 through 3. They wanted you to figure out a z. And whenever they want you to figure out a z, you want to find an equation that has that alone on one side and then this equals here so you can figure out what z is. But I'm just warming you up for the next two questions, which is the question about 4, which is what Charleston's score corresponds with a z-score of 2.2. They're in their way they're saying what x corresponds with a z of something. So if you're asking what's the name, what's the x, then this isn't going to work, right? Because you can fill in the z, but you want to know about this x. So that's why I just did a little makeover, and now we have the equation over here where we can figure out the x. So now that I explained that to you, don't 4 and 5 look pretty easy? Let's do 4. Okay, so in 4, what is x equal? We don't know, so we're going to figure it out. So we're going to use this equation over here. So do we have the ingredients? Okay. Well, we know we have these two ingredients, right? Because they're right over here. But do we have the z? Well, sure enough. Now the z's in the question. Remember the x was in the question before. Now we have the z in the question. Okay, so now we know what we're doing. And we're going to do z. So, I have to rewrite this each time. Z times this plus, the population standard deviation plus the mu equals the x that we're trying to find. So let's just fill it in. We've got to use a pretty color. So z is 2.2, 2.2 in the question. And then we got our old friend standard deviation we keep using. Um, and then what's next? Plus mu. So what's mu is 4.3. Now, before we get there, I just want to point out the mu here is 4.3, right? And the z-score is 2.2, and that happens to be positive in this question. So we're going to expect an answer that's above the mu, right? Because stuff that's above the mu then is a positive z-score. I'm, foreshadowing. This negative z-score, we're going to expect that to be below the mu because that's just the way z works. Okay, well, I did this already out for you because I didn't want to make a mistake on doing the video and get the totally wrong answer. So the answer for that is, what is the z-score? Is if you do this equation out, what you're going to get is 9.8. So that's the x. I'm sorry, did I say what is the z-score? That's the x, okay? Now, I just want to bring it back down to earth. Oh my gosh, 9.8 is huge. A Charlson score, remember how I said that's how many comorbidities you have, or a score of comorbidities? Icola, that's too much. Poor guy, poor guy. Poor lady, poor lady. All right, so the reason I'm going to erase this is I just am going to recycle and do question 5 on the slide as well. We'll keep the purple. What's the challenge here? What are we going to do? Well, we're going to do this one differently here, this 1.1. So now we're going to do negative 1.1. Remember, that's below. And we're going to multiply that by, let's see here, by the standard deviation, because that's the z. Remember, we're doing this thing. And I should have memorized this now. Why am I hesitating here? I have no idea. Plus, and then 4.3. And remember, we're going to get something less than 4.3 because we use this negative z. And what do we get? Well, let's see here. I did it before. And here we get 1.6. And I was right. That's less than 4.3. So here we go. We have the answer then to question 5. Okay, moving right along to question 6. Now we get the unusual question. See this? Unusual. So you learn a person in the population, in this particular population that matters, had a Charlson of 5. Would you consider that unusual? And I remember the first time I got that in biostatistics, I'm like, I'm a very open-minded person. I don't make judgments about what's weird and what's not weird. I'm pretty open-minded, but they don't mean unusual in that way. What they mean is the thing about how likely is it that you would get that. So the secret code is you're supposed to answer with response to standard deviations. So let's say the mean, the mean actually is 4.3, right? Well, if something was within one standard deviation of the mean, or well, let's say within above 4.3 within one standard deviation, we just take this and add 2.5, right? So if you add 2.5 to this, 5 and 3 is 8, and then this is 6.8. Already, you've got like 4.3 is the mean, and then you got one standard deviation, and then you got 6.8. And this person we're talking about is 5. They're right there. They're like in between. And if you remember our whole empirical rule, like this is in this little strippy deal. So that's the tall part. So of course they're in there. Now, if this question had been something like 7, right? This one standard deviation wouldn't, you'd have to go out a whole nother one because this ends at 6.8. So the more, and then you'd be in the smaller little piece. Remember the empirical rule? So if your question is to me, well, is 2 unusual? You're telling me, Monica, that 1 is not unusual. So if we went, either side with 1, it's not unusual in statistics land, like being judgmental about it. Is 2 unusual? Well, it's not that unusual, but 3 is definitely out of the ballpark. That's in this little tiny part. So now that I've scribbled all over the screen, let's go back to the question. You learn a person in the population has a Charleston of 5, which we determined was really close in the middle humpy part. Would you consider that unusual? Now you see that since it's in the middle humpy part, it's actually common. That's what they mean is would you expect to see that? So let's go try to answer the questions. We have the choice between A, B, C, and D. And so is it unusual? A is no, it is within one standard deviation of the mean. So you've already figured out that's going to be the right answer. Okay, well, let's just go through the other ones. Yes, it is within 2 standard deviations of the mean. Well, that the problem there is yes, it's not unusual if it's within 2 standard deviations of the mean. That's like all that. That's definitely normal for this group. So forget about that one. B isn't right. Then C is yes, it's unusual. Okay, it's not unusual, so all these yeses are wrong. But I just wanted to say, yes, it's unusual. It is more than 2 standard deviations higher than the mean. So if that was the case, that would be in here. It wasn't. I could replace that 5 in the question with something really big up there, and then you'd be answering C. But that wasn't the question, so you don't answer that. And then D is the opposite version. That's down here. That's weird on the downside. Again, 5 was near the middle, so you aren't going to say D to this. But think about the test. All right, question 7. Now the quiz prep's getting a little harder, right? So let's look at this question. For a random person in the population studied, meaning the population with this going on in it, what is the probability the person, so the X we draw, will have a Charleston of more than 2? So before I go forward with this, because it's an upsetting question, it's going to involve math. I'm not that good at math. I like to draw a picture. So what is that picture of? We're going to draw a normal curve because remember that's what this is all about, right? And let's start with drawing this little line here. And then what I like to do is I'll put C. C stands for Charleston, right? This is Charleston line. So we know at this line we're going to put a 4.3 because that's the mu, right? Now, then I sort of change color, and then below it I put Z land. Remember the Z we learned about? So we know by definition that Z is 0 here. That's why negative Z's are on the left side of they're lower than the mu, and positive C's are higher, which already is going to give you a hint, right? So now I'm going to be done with purple for a second. And so that so far so good. We just drew a picture. Nothing's hurting anybody yet. Then what is the probability the person will have a Charleston more than 2? So for this, remember x is always in the question. We're going to say x equals 2, right? So where would 2 be on our curvy deal? Well, obviously it's going to be below 4.3. So I'm just going to arbitrarily put it here. It doesn't have to be perfect. So that is where 2 is. So I just drew the line. Now the question becomes, what part of the shape do I want? Because I just want to remind you that when you have a shape like this, it doesn't have to be that shape, but when you have a shape like this, what you do is you draw this, and the whole shape equals 100%, right? So if you do something like this and you say, here I cut off this little part here, and I'm just going to say that's, I don't know, 30%, then you can already know that the rest is going to be 70%. Okay, that's just how these curve things work. Or any shapes actually work like that. We could be in geometry class. We could be drawing other shapes, but instead we're stuck on the normal curve. Here we go. So it's important to figure out what the question's asking. When it says more than 2, it's talking about, let me just show here, this whole section here, which is, how big is that? Is it 60%? Is it 70? Whatever. We don't know, but we know it's bigger than 50% because it crosses this little thing. Okay. Now, if instead I misread the question and it said less than 2, I'd be looking for baby fish. Look at that, it's so cute. It's smaller than 50%, okay? But so that's why I'm going through this whole thing where we're drawing this stupid picture, because if I don't do this, later in the equation I get all screwed up and I get the wrong answer. So we have to draw the picture because of my limitation. So here's a picture, and now we're going to get even exciting more about it. I'm going to color it in. Why am I coloring this part? Because this is the big part. This is the more than 2 part, okay? Okay, I hope that this art, well, hope you're a better artist than I am. Okay, so that's this now. So we know we're looking for the big piece. Okay, that was that's what this whole thing was about. Okay, now we're going to go back to what we were doing for questions 1 through 3. Okay, in which was we were finding z-scores, which is why I still have the z-score thing up. Well, what are we going to find the z-score for? We already made sure that we got our x under control. So let's do our z. So z equals x minus mu over standard deviation. I just rewrote literally what's in the upper left hand corner because I always have to do that for some reason. Now we're going to fill it in. Let's choose purple. So this is going to be z equals 2, right? 2 minus, what is it, 4.3 divided by 2.5. So now we're getting a z, and you're like, okay, we're getting a z. So we're going to get this z, and you're not going to be surprised it's negative because it's less than the mu, and that's negative 0.92. Okay, so that's our z. I'm going to actually, well, let's make it orange. So this is our z. So let's get back to the question again. For a random person in the population studies, what is the probability the person will have a Charleston more than 2? Well, we handled the more than 2 by making this little picture. And now we have a z, so what does that mean? How do we get the probability? Because that's what we need to do. Well, the first thing we do is we look it up in the z table. So I got the z table here. You know, I hope that it gave you whiplash. You can find in your book, see this appendix A8. So here's the z table. And I just want to sort of remind you, we're looking for z equals negative 0.92. Okay. So this is a 2-page table, right? And see these 2 pages. We're going to start on the first page and see that it starts at negative 3.4 on this column under z. That's where we should be looking. And we go all the way on negative, negative, negative. Now it's getting less negative. And then on page 2, it's all positive. So we know we need the negative side. So, okay, so we get the right page. And then, of course, I have terrible memory. Negative 0.92. Okay, so it's 0, not this one stuff. Here, 0.9. There we go. There we are. 0.9. But then where's the 2 part? This is so confusing. You have to go across and find the 2 part up here, which is the 3rd column. It's going to be hard to see, but just memorize this is the 3rd column. And at the intersection is where you're going to find the probability, which I said it was the 3rd column. It's 0.1788. So before you try to understand that, you just write down. What I always do is I go PR equals 0.1788. Okay, we just write that down before we think about it. Okay, now that we think about it, we go, what does that mean? Well, remember back in empirical rule where I asked you a bunch of questions that were actually relatively easy compared to this. But I'd say, okay, what percent of the data is between such and such and such and such? And then I'd say, oh, what is the probability somebody's between that? And I said, by the way, percent probability, it means the same thing. Well, this means the same thing. This is actually saying what proportion of this big blob is at z equals a negative 0.92, because basically what you just figured out is that, see how this is, I'll go back to purple here just to be clear. See how C, you don't know where I'm pointing. C here at C, Charleston was at 2 and then 4.3. And then in Zealand, you know, we had 0 at Port Farm, but we didn't know what to put it to. Well, that's actually negative 0.92. So this probability, now let's get P in the mix. So we have this P, And what is that referring to? Well, if you look at this probability and you go turn it into a percent, which you can do by going 1788 and going loop loop like that, then you can turn it into a percent. So 17.88. You got to make the noise loop loop when you do that. And of course, I hate all these decimals, so I'm going to round it to 18% just for demonstration purposes. So now that's like 18%. So if I put 18% over here, the first thing you're going to notice is that 18% is little, right? Like if this is 18% of the curve. I don't want that. I want the big purple part. So that's why you drew the picture in the first place. Is once you get this probability here, you don't have to turn it into a percent, but I always do because my brain doesn't work otherwise. And then I go, oh, is this a little piece or the big piece, right? Well, I found the little piece, but I really wanted the big piece. So how do we solve that? Well, I'm going to go back into probability land. I'm running out of colors, right? So here's probability. This is how you solve it. You know that 0.1788 is the little piece. And you know the whole piece together, the whole thing together is called 100%, which if you go backwards, dilute, dilute, is 1.0, right? So I could go 1.0, right? Minus, this is our cute little piece, 1788. And you know, I rounded it to percent just to do my demonstration. You really go back to probability and do this. And so if we do that, then we get the answer is 0.8212. And that is the probability. That is what you're looking for. Okay? So just to remind you, what we did was we did these steps. We read the question, then we drew the picture to make sure we knew what we were doing. Then we figured out where x was and we calculated the z. Okay. Then we looked up the probability for this z in the table, right? In the z table. So that was number 3. And then finally 4 again. See, I'm going to put a 4 over here. Is we looked to make sure that the probability we got was the right piece, and it wasn't the right piece. If it had been the right piece, if the question had been, we'll have a Charleston score less than 2, well, that makes sense. We got the answer. But since we needed the other piece, then we had to do post-processing up here, which is number 5. And we'll go through this again with the next question. And just to remind you what the actual quiz looks like, here is the answer to question 7 in the quiz. Of course, I drew this little picture for you when I give you the answer, but the question doesn't have room for that. Instead, question 8 asks, which of the following shapes corresponds to the section of the z distribution associated with a Charleston more than 2? Well, now you're a pro here. D is the correct answer. So now we're going to move on to question 9, which is similar to the question we just did. Which one was that? 7. And but it asks a slightly different question, so we'll get a little more practice. And now we'll jump into question 9. So this is a little similar. So remember our steps. The first thing you do is draw a picture. It just helps you relax, okay? So for a random person in the population studied, what is the probability the person will have a Charleston of less than 4.5? So let's draw a little picture. We start with the normal curve, right? And then we draw a line down the middle. And then we'll make this C for Charleston, right? And then we know in the middle it's going to be 4.3. Now we're all set up. Okay, now we get to the question. And the first thing we do is we figure out x. So x equals 4.5 because that's what's in the question. And then we drop a line down on our normal curve of where 4.5 might be. So that's going to be above 4.3, right? So maybe it's really close here. 4.5. Okay, again, we get back to the question. It says less than 4.5. So that's going to be coloring in this whole part, but you see we cross the middle line. So this is sort of a secret foreshadowing that later when we get our probability a long time later, we're going to ask ourselves, you know, is this the big piece or the little piece? And we're going to want the big piece because notice how that crosses. I'm going to choose blue here. I just want to remind you that z down here on the z scale, 4.3 is always at 0 because it's the mean. But what we're going to expect when we get the z-score for 4.5 is we're going to expect that it's positive. Just we're going to have to be careful with our probability and make sure we have the big piece. Okay, so let's move on to the next step, which is calculating what is the z-score for 4.5. Like, that's an obvious omission here, so let's go. And we have our z formula, we have all our ingredients. Let's just set it up here. Of course, I always have to rewrite it because otherwise I go crazy. Over standard deviation, so let's just fill it all in. Z equals, so x is 4.5 minus 4.3, and we know, and then this is all going to be over our old friend 2.5, and then now we're going to get our magic z, and our magic z is why isn't this 0.08? Okay, so what do you do with a z? You look it up. That's what I teach my class. What do you do with a z? You look it up. Well, where do you look it up? In the z table. So remember this confusing table? We're going to go switch back to that. 0.08. Let me just make sure. Is that it? Yeah, 0.08. So keep in mind where all the O's are. Now notice on the first page of the z table, everything's in negative land, so we don't want that. We're going to go back here. So 0.1, wait a second, 0.08. We got to stick around up here. So really pay attention to your z's and don't get confused if a z looks like a p, right? Just keep in mind what's going on. So 0.08, you go all the way out to the 08, and what do you get? You get 0.5319. So that's a probability. We just have to ask ourselves, is that the right side of the equation? So we're going to go back. What did I even just say? 0.5319. So I'm going to change colors just to remind us. PR equals 0.53. Why does that say 5319? I can't talk and write. Okay, 5319. What's the first thing we notice about this is, remember my little joop joop? If we do that and we get like 53%, we know that 53 is bigger than 50. It's bigger than the half, right? So remember how last time we had to do all this post-processing because we wanted the big piece and we didn't get it? Well, this time we were really lucky. We got the big piece. So now the answer, we already have the answer. We don't have to do this post-processing. So the answer to the question then is 0.5319. And if you just sort of reality check yourself, just imagine you had 100 people, these kidney dialysis patients, and they really did, if you measured their mu and their standard deviation, it really came out to that. What it means is that if you went to go grab somebody out of the crowd with a Charlson of less than 4.5, well, that's a little more than half of the people, so about a little more than 50%. When you grabbed them, that they would have that attribute. And I just wanted to show you a screenshot of the answer here. Much more neat, you know, when you can have some time and you aren't just drawing these normal curves on the fly, you can make them very nice. But still, the answer is the same. So yeah, so let's move on to question 10 because that's a little harder. Okay, question 10 is a little long and involved, and the main reason is because we have two x's. Remember the earlier question where you had, you know, you had to look at the z's for between a certain Charlson and another Charlson? Well, when you actually are looking for the probability, which is what question 10 asks for, there's a lot because you have to go through all the steps for each side of the x. Okay, so well, let's just get started. So for a random person in the population studied, what is the probability the person will have a Charlson greater than 1.5 but less than 5? And it's just easier to draw the picture again. So here's a picture. Here's the line. 4.3 is, you know, our Charlson score. And then we remember how I taught you you can do this x1 equals 1.5. You can just arbitrarily assign them. I just do them in order. X2 is 5. So we have two x's we got to deal with. So let's put an x1 on our little picture. Well, we know 1.5 is less than 4.3. We don't have to be perfect about it, but we're going to put 1.5 in here. And we know 5 is more, so it's on the other side of the hump. So here's 5. Okay, now let's go into Z land. So in Z land, again, we know this is 0. But our first step is we're going to have to figure out those. I mean, we're just going to have to figure that out. That's what we had to do in the previous question. We have to do it here. But before we go forward, I just want to make sure you understand that at the end of the equation, at the end of this whole problem, what we are looking for, just like in the last problem, last few problems, this is probability, but we're looking for this middle piece. Now, you're probably wondering, well, I just taught you how to find a greater than or a less than. And I just taught you if you cut this shape in half and one side is 70%, the other side is 30%, whatever, how are you going to deal with this one? Well, there are 3 different approaches. Okay, and I'm going to show you the approach that my student taught me is probably the easiest. The first approach is you can find the whole probability here all the way to the top of anything greater than x1, which is 1.5. And then as a next step, you can find the whole probability of everything above 5, x2. And then if you subtract the second one, this little piece, from this big one, you'll trap the middle in there. So that's the way I always did it. It's not really a great way. Then you can kind of guess the next part. Then the other, a second way you can do it, and you'll get the same answer, is you start with x2 and you first figure out what the big piece is for x2. Then you figure out what the little piece is for x1, and then you subtract that little piece from the big piece, okay? Well, what my student pointed out is, wouldn't it be just easier to figure out what this little piece is, whatever's bigger than x2? Keep track of it. Figure out what this little piece is, whatever's smaller than x1, keep track of that, and then just take 1.00, which is the whole darn shape, minus the probability for it to be greater than x2, which is this line right here, that probability, minus the probability of it being less than x1, which is this little thing. So as you can see, as I go on, you're starting to probably go, okay, this is really boring. I kind of get it now. This is reminding me of geometry. Sorry about that. But I just wanted to be clear that we're going to do the third strategy, but the other two would work and you'd get the same answer. Okay? So let's do the third strategy, which was, here, I'll leave it on there, where we're going to find out the probability of the little piece, the probability of this little piece at the top, and then get rid of those two from the total, and that's how we're going to trap this middle part. Okay? So that's our plan. We're sticking to it. So how do we do the first one? So the first one, we're going to do x1. We got a z x1, then find the probability, and then do that green arrow thing. So let's z it. Okay? So I'm going to go back to purple here. So remember, I have to always rewrite things. Z equals x minus mu divided by standard deviation, and then let's fill that in, which is using our x1, we're going to say equals 1.5 minus whatever mu was. I should memorize this, 4.3 divided by 2.5. What's our z? What's our z? Oh, 1.5, you know, is below the mu. So we're going to have a negative z. Negative z. I hate to be so negative about our z, but here it is. Negative 1.12. So notice 1.12, and notice it's negative. So why am I saying all that? Because we're going to have to go over the z table and go look it up. It's a clumsy table. So negative 1.12. Well, I'm starting on the positive side, so I'm definitely in the wrong place. So negative, here we're in the negative 1 department. Negative 1.1, and then we need the 2 column, which is the 2 column. That's the third one over. So negative 1.12 is 0.1314. So let's hurry up and remember this. So PR equals 0. What did I say? 1314. So if you do that thing in your head, that's like 13%. That's really little. And so we got the little piece. What were we doing? Oh yeah, that's right. Well, let's go back here to look at what we were doing. That's what we wanted. Is we wanted the probability of less than 1.5, and that would be a little tiny piece, like 13%, so we got it, right? So I am actually just going to write this over here because I know I'm going to forget it if I don't. So 1314. So that's the probability, take it up by that little piece there. And actually, maybe there's some way to clean all this up. Let me just clean all this up because we got to do x2, right? We aren't ready yet to end this problem. I'll leave my little uh, formula there, but now we're going to do, whoops, we're going to do x2. So what is x2? Well, x2 is 5. So let's plug 5 in. 5 minus 4.3 divided by 2.5, and what do we get this time? We get 0.28. I think we did this one before. You know, it's not cheating to save your answers from the earlier part of the quiz and reuse them if they're still correct. It just speaks to the quiz master who made it, which is me. All right, so now we have a new z-score. What do you do with a z-score? You look it up. And I just want to make a public service announcement here. See this z-score? It's sneaky. It looks like a probability. Do not be fooled. Just because it's little like that and just because it's positive doesn't mean it suddenly gets to be a probability. It is still a z-score. So keep focused, okay? We have to look that up. It is not a probability. And now what I'm going to do to look it up is memorize it and go try to look at the z-table. So 0.28, 0.28. Well, we're in the wrong department here. 0.2, and then we'll go over to 8. 0.28, 0.6103. Okay, so just remember that for now. So PR equals 0.610. What did I do? 6103. Okay, now let's reality check ourselves. Remember, if you do that, you see 61% in your head, if you're me, if you have a vivid imagination. But if you go over here to our picture, what do you think 61% is? We want this little tiny piece at the top. Well, that is not 61%. That 61% is the rest of the curve. It's a whole biggie because it's more than 50% and we want something less. So you know what we have to do. On this one we have to do the post-processing step. So what is that? Well, that's where we start with 1.0000, and of course if you have a calculator this goes way easy. You don't have to put in all these O's, but then minus 0.6103 so we can get the other little PC. And what do we do when we get that is, I didn't do it out so I've got to do it on the fly here. So 10 minus 3 is 7, right? And then 9 minus 0 is 9, isn't it? And then let's see here. And then 10 minus 1 is 9. I probably shouldn't be doing this. And 9 minus 6 is 3. So we end up with 0.3997. Okay, so that's the other side. So we're going to put that over here. 0.3997. Okay. Now that we've gotten these two little pieces, if we take 1.0000, and again use your calculator, and we minus both of these, we do minus the first one, which is 0.1314, and then we also minus from that the second one, which is 0.3997. We're going to trap in the middle of the purple part, and the answer for the purple part will be 0.4789. Okay, and so I know that was a lot of steps, but that's kind of what you have to do when you have two x's, is you have to well, I'm showing you the third way. You have to find the probability of the little piece here, and then the probability of the big piece here, which is enough trouble, and then subtract both of those from the whole, and that's how you'll get the middle purple part. So quickly, I wanted to circle back to quiz prep the answers I posted. So remember, question 10 is what we just did. We went through all the sound and fury just to get one little answer here. But then the next question, question 11, is which of the following shapes corresponds to the section of the z distribution associated with the Charlson of greater than 1.5 but less than 5? Well, you're all used to it. It's that middle banded part here. All right, we are almost done. Just a couple more questions. Okay, second to the last question, and this one looks a lot harder than it is. Okay, so let's read the question. Imagine that the investigators, the researchers, became concerned at some of the high Charlson scores they saw. I mean, this is actually personal. I was like, whoa. They decided to give free treatment to people with Charlson score 7 or higher. So what do you think x equals? Of course, it's going to x is in the question. So x equals 7, and they say 7 or higher. Notice this is kind of like the other questions we've been doing, but this asks the final thing slightly differently. So what percentage of patients will receive free treatment from the investigators? It's just a fancy way of saying you got to do the doop doop thing and turn it into a percent. But we're gonna just exercise here. We're gonna exercise our z-score muscle. So what are we looking for? Well, it's what do we do when we're scared? We just draw a picture, and then in the middle of the picture we put a 4.3 because we're talking about Charlson. And then we go put x down, which is 7. So that's way up here, 7. Okay. Now we'll just relax. We'll go into Z land. And we're going to say Z. We know that this is a 0. We don't know what this is, so that's going to be our first step. But also, what are we looking for? We're looking for 7 or higher, so we color in this part, right? So we start this whole thing just like we normally do. And then we fill in the equation. First I have to obligatorily rewrite it. And then that equals, I can write it below it, 7 minus 4.3 divided by 2.5. So what does that equal? I already worked it out. It's 1.08. So what is that? That's a z-score. What do you do with it? Look it up. So we're getting ready for probability. I'll turn orange here. So 1.08, 1.08. So we know we're not in negative land, we're in positive land. 1.08, so we have 1.0, okay, 1.0, right. And then we got to go over to 8. 1.0, where's 8? This is 8, right? Oops, that didn't work. 1.08, my eyes are so bad. So this is 0.8599. So let's just write this down before we forget it. So this is the probability P R equals 0.8599. Gosh, it's ugly here. Let me do this nicely here. Whoops. So it's really 8599. Okay. There, I don't want to confuse you anymore than I probably already have. Okay, so that's the probability we got. Now, you remember the trick I taught you is the reason we drew this is we're looking for this little piece. Well, is this a little piece? We go doop, doop. We're seeing like 85, 86. Okay, that's not little. We're going to have to do the 1 minus thing, right? So let's do the 1 minus thing. So we'll go 1.0. I always draw these O's out just so you don't get confused, but really on your calculator, you just put 1 minus 0.85. What is it? 9. And if you actually do that out, you're going to get 0.1401. Now that's more like it. That's this little piece over here. But if you put that answer, it technically wouldn't be correct because they're asking for what percentage. You really have to do the doot doot thing. So we go doot doot like this, and you would get then 14.01%. Well, you can round it. It says something like in the question you can round it, I think. But anyway, so then the answer to question 12 is 14%. Okay, here we are on question 13. And this is a little tricky, but I'll walk you through it. Imagine that the investigators realize they cannot afford to treat more than 3% of their population. And this would be the top 3%, the sickest ones. Given this, at what Charlson score will patients receive free treatment? So basically, we know that the mu of this population is over here. It's 4.3. And we know that somewhere above there is a cut point for the top 3%, but we don't know what Charleston that is, and that's what the question is asking. So before you get too confused, let's just draw a little picture. That's my solution to everything. So we'll say ch, and we have the mean here, 4.3. And somewhere up here is the top 3%, right? So we'll say, I'll use orange, that's sort of my key for probability or percent. So we'll say that's the top 3% is what we're looking for, okay? But in red, we have Charleston. And of course, we can pull out our purple here and do Z. Here's Z. We know that's 0. And also, we don't know the Z for that one. Yeah, so now how do we approach the question? Well, as I've taught you in earlier parts of the video, if you have a Z, which we don't have this time, but if you did have a Z, what do you do with Z's? Well, you look them up in the Z table. But what if someone, instead of giving you a Z or giving you an X, like if somebody gives you an X, you can calculate Z, right? And if somebody gives you a Z, you can look it up in the table. But what if somebody gives you a percent or a probability, right? That's what they did. This is the message. Dig around in the middle of the table. Okay, so if they give you a Z, look it up. If they give you a percent or probability, dig around in the middle of the table. So you're saying, what do you mean by dig around in the middle of the table? Well, this is what you do. First, remember my little doop doop thing? That's how I get percents. We're going to have to backwards that and turn this into a probability. So how do we do that? Well, we go back, doop doop, and we get 0.03 and then 00 because we're trying to make it match what's going to be in the Z table. Then we move over to the Z table and we dig around in the middle of the Z table, okay? So you'll notice here we're in the middle of the Z table. If you're over on the positive side here, you'll see this is big money, like 0.8508. We're literally looking for 0.0300. So you got to kind of look around. Oh, here we are in the neighborhood. 0.02, here's some 0.03s. 0344, 0307, 0301. Perfect. That's really close. Now, if we had been sort of halfway in between, like I didn't want you to look for 0.0300, but I wanted something like a little bit maybe between that and 0.0307, you know, you'd have to split the difference. You'd have to look and see which one was closer, but on my quizzes, you got enough to worry about. I try to pick an obvious probability since you're digging around that table anyway. Okay, why? Why did we look up this? Well, because we know if we find a probability, we can figure out the z-score at it by looking at the row in the column. So let's just go narrow them over here. So this is at negative 1.8, and then what is this column? That'll do the hundredths. Negative 1.88. Okay, so let's quick write this down before we go too far. Let's use purple. Now, what we got was negative 1.88. But again, I'm glad we drew this picture because if you wanted the bottom 3%, you'd use this negative 1, right? So this is, whoops, I probably should use this. Here's the bottom 3%. Bottom 3%. That's going to be at let's get our z here, negative 1.88. So you definitely don't want that z. So what's going to be the upper one? You know, the top. We'll say top. Well, it's pretty easy actually. You just make it plus. You know, because this is 0 here. See, and it's a mirror image. So we'll just fill this in, plus 1.88. Wasn't that easy? So again, when you have these, you want to draw the picture because you just want to make sure when you get to this point, you're using the right flavor of z-score, with negative or positive. If sometimes you get a question of like, well, what are the worst or the bottom, you know, 9% or whatever. In which case, then we would have kept the negative 1.88. But if they don't want the bottom and they want the top and you get a negative, just flip it around. I mean, it's so simple. You don't even have to do any equation or anything. Okay, so this was a long way of getting to our z of 1.88. Well, why did we even do that? because ultimately we're going for an X, right? Remember, we wanted to say at what Charlson score, and that's our X here. And we couldn't get to our X unless we had a Z, right? Because you need a Z in this equation. I mean, we had the other two things, but what Z were we going to use? Okay, now we're ready. We got our Z. So let's go and calculate that. So I'm going to write out the equation. So just to remind you, we're using this equation equals Z times the population standard deviation plus mu. And then in our case, we painstakingly got this Z, which is positive because we're at the top. And we're going to times that by our old friend, population standard deviation we've been using, plus, and then here's our mu, 4.3. And if you do that all out, you're going to get the X you need. And the X you need is actually 9. So that's a Charlson score. So here 9. So what would happen is, you know, you go in the room, hey, guess what? People are going to get free treatment. Who's going to get that? All you 9Zs and over. You're going to get free treatment. So hooray, that's awesome. Yay. Okay, we're back. I won't delay you any longer. This is the longest video in the world, but this is a really hard chapter, chapter 7. Aren't you glad I split it up? But in any case, okay, so we're at the end of chapter 7.2-7.3 quiz prep. We went over how to calculate z-scores. We went over how to look up probabilities, and we did some fancy stuff at looking at probabilities maybe in the middle of the curve. We figured out how to back calculate x's from z's and other ingredients, and we talked about what happens if you are given a probability or a percent, how you do those um, kinds of questions. And here I'm showing you on the screen the answer to question 13. Like I said, lots of sound and fury signifying only one little answer, 9. But that's the story of chapter 7, okay? So congratulations on making it through this kind of difficult quiz prep, and I just know you'll do well on the quiz. Good luck.